All right, guys, today we are going to look at lesson 2.4, which is congruent figures. So our learning target today is to understand the concept of congruent figures. Our success criteria: I can identify congruent figures and I can describe a sequence of rigid motions between two congruent figures. A rigid motion is a transformation that preserves length and angle measure. So rigid motions are translations, reflections, and rotations. All right, so congruent figures are, two figures are congruent when one can be obtained from the other by a sequence of rigid motions. Congruent figures have the same size and same shape. Angles with the same measure are called congruent angles, and sides with the same measure are called congruent sides. The two triangles below are congruent. The corresponding angles of congruent figures are marked with the same angle measure. So you can see angle B and angle E each have one swoop on them, right? Angle C and angle F each have two, and angle A and angle D each have three. Okay, that same thing goes for the corresponding sides. So the corresponding sides, AB is marked with one tick mark, as is DE. BC is marked with two tick marks, as is EF, and AC doesn't have a tick mark, nor does DF. So you can see when those are labeled below, we use the line on top to indicate a segment. So if I read that, it would be segment AB is congruent to segment DE. So that equal sign with the squiggle on top means congruent to. Okay, and that line above means we're talking about the segment, okay, which in this case is the sides of the triangle. The angle, okay, we use that triangle arrow type marking to indicate the angle. So it says angle A is congruent to angle D and so on. So when we are marking congruent pieces, we need to mark them in the correct order, matching the corresponding angles or the corresponding sides. So here, the triangles that I see that are congruent is triangle DFE is congruent to, so if that matches, it would match with MPN, okay? And I have to write it in that order. Okay, and then again, I use that triangle marker to show that I am talking about a triangle here. The other triangles that would be congruent in this picture is triangle CBA would be congruent to LKJ. Okay, so notice, right, I started at C and I went up on the diagonal. So when I started at L, I also had to match the diagonal, right? Those two triangles are reflected over the x-axis, and I need to match the angles that are congruent, right? So C matched with L, B matched with K, and A matched with J, right? I do not want those markings there, so I'm going to get rid of them. All right, awesome. All right, for the second example, it says the dashed figure is congruent to the solid figure. Describe a sequence of rigid motions between the figure. So in order to do this, on the figure, you can see that they are labeled I and PI, right? Because PI is the pre-image and I is the image. So I am trying to get the dashed figure, right, to the solid figure. So looking at that, my dashed figure, I picked the blue point on each of those figures because those points match, and that's going to help me describe my motion. So I can see that I started at the ordered pair 7, 5, right? And I want to end at the ordered pair negative 5, 6. All right, so what I see happening here is the first thing I'm noticing is that the shape was rotated 90 degrees. And that is counterclockwise. Okay. The rule for rotating counterclockwise would be negative yx. All right, I'm going to move this piece down here. All right, so if I actually applied that rule that I just came up with, and I started at 7, 5, and I applied the rule negative yx, that would put me at negative 5, 7. Okay, and remember my goal is negative 5, 6. So what that tells me is my next step, I need to translate 1 down. Right, so here I'm going to keep my x the same, and I'm going to subtract 1 from y. Right, that would put me at negative 5, 6, which was my goal. Okay, and if it worked for one of those ordered pairs, it's going to work for the rest of the ordered pairs in that figure. Okay, so my answer is that sequence, okay, which is rotating and then translating. Okay, a lot of times for these, there is more than one correct answer. Okay, so if you came up with a different sequence of rigid motions, just check with your coordinates to see if they work. Okay, this was the one that I saw. All right, and then our final example here. It says you can use the buttons shown at the left to transform objects in a computer program. You can rotate objects 90 degrees in either direction and reflect objects in a horizontal or vertical line. How can you transform the emoji as shown? All right, so I came up with 2 different options here for getting this emoji. So, right, we started with this smiley face with the tongue on the right. I am going to rotate it in a, clockwise direction, which is going to give me an emoji that then looks like this. Right, and then I am going to flip or reflect across the y-axis, right, which would then give me the emoji that ends like the picture shown. All right, the other option that I came up with for this sequence would be, again, to start with our original. And this time rotate the opposite direction. So I'm going to rotate counterclockwise. So if I rotate counterclockwise, right, that would give me this image. Okay, and then to get it to the final image, I would have to reflect this horizontally. And if I reflected horizontally, it would take me to that final image once again. All right, guys, that is it for the notes today. So you can go ahead and put away your notes packet and go back on the agenda to check what else you have to do today.